Hi, I'm Marco. I'm a fourth year in the mechanical engineering department, and I've been on the team for 3 years. And I will show you how to create this pulley that you see here. First, we need to open up Solidworks and create a new part. Make sure that the unit system is set to IPS. This means that the standard units used for all the measurements will be in terms of inches, pounds, and seconds. This is shown in the lower right corner of your screen. If you want to change your unit system, you can select any one of the options that are present. We will start by creating the circular body for the pulley. To do this, we go over to the Sketch tab, which is right next to the Features tab at the top of the screen. Select the Sketch icon under the Files tab and select the plane that you want to start the sketch on. For this example, I will select the front plane. To the right of the Sketch button that we just pressed is all these options for different types of shapes we can draw, such as a line. With the Line tool, the line automatically connects to each of the points where you click. If you want to stop and create a line somewhere else, you can press the Escape key. You can also draw lines by pressing the L key on your keyboard. You can also create rectangles. With the rectangle, there are different options for how to create the rectangle. Typically, the default is set to using the corner points of the rectangle. If you press the arrow button next to the rectangle button, then you get more options for drawing the rectangle, such as center rectangle, where you click where you want the center of the rectangle to be, then one of the corners of the rectangle. With a three-point corner rectangle, it works the same way that you use the standard rectangle is drawn, except instead of selecting 2 points, you have to select 3 points. This is useful for drawing a rectangle at an angle. You can also create circles. We can draw a circle to any size anywhere on the screen, and then press the green checkmark button. Now we have to make sure that this sketch is fully dimensioned so that all the needed measurements for this part are accounted for. If we don't do this, we can have a variety of parts that all meet the requirements that are set, but only one of them is the one that we want. So let's start by moving the center of the circle to the origin. We do this by pressing Ctrl and click on the origin and the center of the circle. Then this will open the Properties menu on the left. In this window, select Coincident so that the points line up with each other. Then press the green checkmark button. Now we have to set the diameter of the circle using the Smart Dimension tool at the top of the screen. For this example, we will set it to 3 inches. So click on the outside of the circle and press 3 and enter. To check to make sure that this sketch is fully dimensioned, all the lines drawn will be black instead of blue. It will also state fully dimensioned in this box at the bottom right side of the screen. It is possible to overdimension a part. This is done when you have more constraints present on a sketch or part than you need. I will show this in a new sketch on the same plane. I will draw an overdimensioned rectangle. Using the Smart Dimension tool, we will constrain it so that the origin is 2 inches away from the bottom and left side. Also, the overall bottom and left side will be 4 inches. So to over-dimension this part, let's add a dimension to the right side. A pop-up window appears asking how SOLIDWORKS should treat this dimension. Select Leaving Dimension Driving. So you should see the box in the bottom of the screen that this sketch is over-dimensioned. So let's right-click and delete this sketch. Now we go over to the Features tab and select Extruded Boss/Base and select the sketch that we want to extrude. Now we set the depth to 0.75 inches. Now we will work on creating the plates for the rope to sit in the pulley. Right-click on the right plane option on the left of the window. This will change the orientation so that way we are looking at the pulley from this side. create a new sketch, click Normal or press Ctrl and 8. The process for doing this is the same as before. Create another circle. We can add a relation while creating the circle by hovering over the center of the top side of the pulley. Make sure that you click on the orange circle that appears. Click again to initialize the size. Set the dimension of the circle to 0.5 inches using the Smart Dimension tool. Then we need to create an axis of revolution for this cut. We will do this by creating a center line going through the center of the pulley. Click on the arrow marker next to the line option and select Center Line. Select Infinite Line in the left menu. Click on the center of the vertical line, move the mouse horizontally to the side, press the green check mark, and make sure everything is fully dimensioned. Go back to the Features tab, select Revolve Cut. In the menu to the left, we can control how much of the part we want to cut around the axis of revolution. For the selected contours, make sure that the circle we just selected, make sure the preview of the cut goes completely around the pulley, and press the green check mark. Now we will create the center hole for the pulley. For this operation, we will be using the Hole wizard under the Features tab. It is located right next to the Extruded Cut button. Under Hole Type, we will select Hole. This is on the top row rightmost column. Then we will go down to the hole specifications and make sure the size is set to 1/4. Then scroll down to the end condition and make sure it is set to through all. If we want the hole to only go through part of the pulley, we could use the blind option and set a specific depth. Then we have to position the hole on the pulley. This is done by going to the Positions tab at the top of the menu under the green check mark. Then left-click on the circular face of the pulley. At this point, the origin of the face should appear. Left-click on the origin to set the hole location there. Then, in the same location, right-click to confirm the placement of the hole. Then, you should see a hole going through the center of the pulley. We will also be adding a fillet to the outer edge of the pulley. This is useful for removing sharp edges that could cut someone or something. So, click on the Fillets button located next to the Linear Pattern button on the Features tab. For this example, we will ensure the fillet type is set to constant size fillet. Then under the fillet parameters, we will set the radius to 0.01 inches. Then select the 4 circular edges that we want to apply this fillet to. As you can see, we select the edges, a preview appears. Then press the green check mark. You can zoom into the edges that the fillet was applied to and see how they got rounded out in the model so there are no sharp edges present. To see the entire pulley from an isometric perspective, click the View Orientation under the Solidworks Cam tab, and select one of the corners of the view cube. So now, you should know how to create a sketch, drawing lines, rectangles, circles, dimensioning, and making sure that a part is fully dimensioned. You also know how to create features such as extrusions, holes using the Hole wizard, creating fillets, and revolved cuts.